So hey guys, I found an interesting question on flow through peg bed as we have discussed earlier. So the question is like this: air at 25 degrees Celsius and 1 atm is flowing through a packed bed. That is that is 1.5 meter long and has a diameter of 0.1 meter in diameter. The bed is pegged with spherical catalyst particles with the particles of diameter 55 mm, which is roughly equal to 0.005 meters. The porosity, also known as epsilon, of the bed is 0.4. The superficial velocity of air has density of superficial velocity of air is 0.25 meters per second. The air has a density of 1.2 kg meter cube and dynamic viscosity of 1.85 into 10 to the power minus 5 Pascal per second. So the question is, using Ergun equation, calculate first the pressure drop across the bed. The pressure drop across the bed second, the Reynolds number to determine to determine the flow regime. Third, the power required to maintain the flow. The power required to maintain the flow if the volumetric flow rate is known. If the volumetric flow rate is known. So first of all, we have to write the given data. So the given data in the question is given solution. First, given data value. So the given data, the bed length, also denoted by L, is given 1.5 meters. Second, the bed diameter, which is 0.1 meter, and assumption is given not needed, no wall effects considered, no wall effects considered. This is done to ease the calculation. Particle diameter, also denoted as dP, is given 0.005 meters. Fourth, porosity, also denoted by epsilon, is given 0.4. Superficial velocity, denoted by V, is given as 0.25 meters per second. Sixth, fluid density or rho is given as 1.2 kg per meter cube. And the last is viscosity or dynamic viscosity, denoted by mu, is given as 1.85 into 10 to the power minus 5 Pascal per second. So first, here the step 1 is to calculate the Reynolds number. So step 1, calculate Reynolds number, which is for packed bed, which is REP is equal to rho, which is fluid density, multiplied by superficial velocity, multiplied by particle diameter divided by mu into 1 minus porosity, which is equal to 1.2 into 0.25 into 0.005 divided by 1.85 into 10 to the power minus 5 into 1 minus 0.4, which is roughly equal to 135.1. So the result of this is the REP value, or the value of Reynolds number, is close to 135, which is in the regime of transitional flow between laminar, which mean between laminar and turbulent range. So the step 2 is calculating the pressure drop using Ergun equation. So the step 2, use Ergun equation to calculate pressure drop. So the formula of Ergun equation is delta P by L, which is delta P representing the pressure drop and L is the length of peg bed, is equal to 150 into 1 minus epsilon whole square multiplied by dynamic viscosity into superficial velocity divided by epsilon whole cube, which is porosity whole cube, multiplied by particle diameter square, plus the second term is inertial term, which is equal to 1.75 multiplied by 1 minus porosity into density multiplied by superficial velocity divided by porosity's cube into dp. First we have to calculate the porosity terms, which is so first we calculate porosity term, which is 1 minus epsilon whole square is equal to 0.6 whole square into 0.36. Epsilon cube is equal to 0.4 cube into 0.064. Next, there are two terms in the equation. First term is viscous term. Viscous term, which is this part. So first we will calculate this, which is equal to 150 into 0.36 multiplied by 1.85 into 10 to the power minus 5 into 0.25 divided by 0.064 multiplied by 0.005 whole square, which is equal to 2.4975 into 10 to the power minus 4 divided by 1.6 into 10 to the power minus 6, which is roughly equal to 156.09 Pascal per meter. Now we will calculate the inertial term. Inertial term, which is this part, second part. This is known as inertial term, this is known as viscous term. So this term is equal to, we will put the value 1.75 into 0.6 into 1.2 into 0.25 whole square divided by 0.064 into 0.005, which is equal to 0.0875 divided by 0.00032, and which is roughly equal to 246.09 Pascal per meter. Now the fourth step is step 4, total pressure drop over length of bed, which is equal to delta P is equal to delta P by L multiplied by L, okay, which is equal to, we would add the both sum which we have calculated, the viscous term and the inertial term to get it the total pressure drop, which is equal to 156.09, we will note this, which is equal to plus 246.09 into 402.18 Pascal per meter. If we have to calculate the pressure drop over length of bed, we have to multiply this term with the length of bed, which is equal to 1.5 meters. So 402.18 multiplied by 1.5 will give us 603.27 Pascal. So this is our pressure drop over the length of bed. Now the third part is the fifth step is step 5 is to calculate power required, which is equal to, for which we have to first find the flow rate, volumetric flow rate of the fluid. So the volumetric flow rate is equal to area multiplied by the superficial velocity, and the area of peg bed is pi d square divided by 4 multiplied by superficial velocity, which is equal to 5 into 0.1 square divided by 4 multiplied by 0.25 meter per second, which gives us the volumetric flow rate is 0.00196 meter cube per second. Now to calculate the power required, overcome power required, we have to multiply the pressure drop with the volumetric flow rate, or power required to overcome pressure drop is equal to P is equal to delta P, which is pressure drop as calculated earlier, multiplied by volumetric flow rate, which is equal to 603.27 multiplied by 0.00196, gives us the roughly 1.18 watts. So the final answers to this question is Reynolds number is 135, which is in transitional flow. Pressure drop is 603 pascals and power required is 1.118 watt. So this is the question, and I hope this question will help to increase your knowledge or increase your knowledge about flow through peg bed. Thank you.